Alright, what's up guys? In this video we're going to pick up with some vector calculus. We're going to evaluate another line integral here. So we have to evaluate the line integral xy plus z cubed ds, where c is the part of the helix given by r of t is equal to cosine of t, sine of t, comma t, and t is between 0 and pi. So let's remember how to evaluate the line integral here. So we'll write down the formula. So remember, for the line integral, it's just going to be the line integral f ds is equal to the integral from a to b. It's going to be f of x of t, comma y of t, comma z of t, multiplied by the square root of dx over dt squared plus dy over dt squared plus dz over dt squared dt. Okay. Now recall that this formula is the exact same thing as the line integral f ds is equal to the integral from a to b, f of x of t, comma y of t, comma z of t, multiplied by the norm or the magnitude of r prime of t dt. Recall that this is the exact same formula, and what I like to do in my videos is make you aware of the different things that things can be written, because a lot of times two things can be written differently, but they're really saying the same thing. And so I just wanted to make you aware of that. That's the reason why I wrote down both forms. But hopefully by the time you get to vector calculus, you'll be pretty familiar with the form. But I'm just saying, just in general. So remember that the ds part is of the formula here is really just going to be nothing more than the square root of dx over dt squared plus dy over dt squared plus dz over dt squared dt. Okay, so now that I've made you aware of all of the information, we'll go ahead and begin tackling this. So let's go ahead and get dx over dt, dy over dt, dz over dt. So let's get that. So dx over dt, what's that going to equal to? Well, all you have to do is remember what the parametric equations are going to be. So x here is going to be equal to cosine of t. Y here is going to be sine of t. And z here is t. So let's go ahead and do it. So we'll get negative sine of t dy over dt. That's going to be cosine of t. And then dz over dt is just 1. Now we'll go ahead and compute ds. So let's get that out of the way. So we'll have the square root of negative sine of t squared plus cosine of t squared plus 1 squared dt. So now let's get the square root of, gives us the square root of sine squared of t plus cosine squared of t plus 1. And recall that sine squared of t plus cosine squared of t is 1. So essentially what we have here is ds is going to be equal to the square root of 2 dt. Okay. So hopefully you were able to see how I got there. And then we just plug it in here. It's basically all we do next. And evaluate the integral. So here's what we'll have. So it's going to be equal to the integral. Remember, it's from 0 to pi. Those were the that was the range for t. And all we have to do is we take our parametric equations. So we'll have x, we'll plug it in, we'll have our y, we'll plug that in, and we'll take our t here and we'll plug that in. Don't forget it's been cubed. And then we'll multiply by the ds. Okay, so what we'll get is cosine of t multiplied by sine of t. And this is going to be plus t cubed multiplied by the square root of 2 dt. So hopefully you're able to see how I got there. And now we just go ahead and evaluate this integral. So the square root of 2 is a constant, so I'm just going to bring it out. And what we'll have is the integral from 0 to pi. And we'll have cosine of t multiplied by sine of t dt plus the integral from 0 to pi, and it'll be t cubed dt. Okay, let's go ahead and integrate this here. All right, so let's deal with the first integral here. So from 0 to pi, cosine of t multiplied by sine of t dt. Recall that I can just write that as the integral from 0 to pi, and I can write that as sine of 2t dt. That's a trig identity. Hopefully you remember that. And when I take the antiderivative of sine of 2t dt, I get negative 1/2 cosine of 2t. It's going to be from 0 to pi. So if we stick in pi, we get negative 1/2. Subtract, if we stick in a 0, remember cosine of 0 is 1. So this would be negative 1/2, which is just going to give us 0 because it'll change to a positive. And then from 0 to pi, we got t cubed dt. That's t to the 4th over 4 from 0 to pi. So clearly when we stick in, what we'll end up getting is just going to be pi to the 4th over 4. So we now got our square root of 2, which is on the outside. Okay, and what it's going to be is basically 0 plus pi to the 4th over 4. And if I simplify this, I can write that as 4 pi, or excuse me, pi to the 4th, all over 2 times the square root of 2 if I actually simplify it, which would be your answer. So your final answer for this line integral here that we were given at the beginning is just going to end up being pi to the 4th power all over 2 times the square root of 2. And that's your answer. Okay, so I've done plenty of videos on line integrals, so feel free to check out some more on my YouTube channel and so on and so forth. And let me know if you got any questions. Hopefully everything made sense. So we'll see you next time.